This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, so welcome to Week 5, Lecture 2, Wednesday lecture before the break. So last week ago, Monday, I gave the lecture on demand, introduction demand, and then we looked at the lecture notes for elasticity, and we got to slide 19. So we'll continue from there. And today what I'm going to do is I'm going to finish the elasticity lecture notes and do the consumer surplus lecture notes. I want to do the consumer surplus because it's on the tutorial 4 questions. So I'd like to get it done, and that way you can use it over the break. Okay, so let's get started. So we're talking about the price elasticity demand. So remember, elasticity is simply the ratio to percentage changes of variables. So the percentage change in one variable divided by the percentage change in another variable. So the price elasticity demand, in fact, all the demand elasticities we're looking for, in the numerator, we're going to have the percentage change in quantity demanded. What's different is what's going to be in the denominator. Now, the price elasticity demand is going to be the percentage change in the price on the denominator. So price elasticity demand, we have the percentage change in the quantity demanded in the numerator, percentage change in the price in the denominator of the good. So it's how responsive is demand to a change in the price, right? How sensitive is demand? Does it change a lot when the price changes, or does it only change a little bit? And the only other thing to note about this is with downward sloping demand curves, that would always be a negative number. So it's often the case that economists would just drop the negative number. Now, it's not universal, so as we're going to see some situations, some economists leave the negative number in, some take it out. So if you're looking at the Serrano and Feldman textbook that I mentioned to you, a short course in intermediate microeconomics with calculus that's available freely online from Cambridge University Press, they dropped the negative sign. Whereas if you look at the other textbook I recommended by Hal Varian, Intermediate Microeconomics, he leaves it in. So you just have to be aware of it. It's not a big issue because either you always drop the negative sign or you always leave it in. So you can always tell which one the economist is using. All right, so that's the price elasticity demand. How sensitive is demand to a change in its price? So we want to say, well, what determines how sensitive demand is to a change in price? Well, what makes demand either more or less elastic? And the first one I mentioned at the end of last Monday's lecture was the number of close substitutes. So intuitively, the idea is if there's more close substitutes, then when a firm tries to raise its price, more customers will leave because there's close substitutes to replace that more expensive, relatively more expensive good. So therefore, demand will fall quite a bit for that firm that's trying to raise its price. In other words, it's very sensitive to the demand is very sensitive to the change in price. And so we'd have more elastic demand, relatively speaking. Right? Conversely, if there's very few substitutes, then when the firm raises its price, what are you going to do? There's not many other things you can do instead because there's substitutes that don't exist. Right? So that's the intuition on that. So I said there tend to be a lot of substitutes for Vietnamese restaurants. Right? There's lots of Vietnamese restaurants in Melbourne. So if one tries to raise its prices significantly, you just go to another one that's still relatively cheaper. And if you consider Asian food in general to be a substitute for Vietnamese food, then you have also all the Thai foods, the Chinese, Malaysian, Indonesian. This is spoken, of course, like a person who grew up without much Asian food. Okay. All right. The second one is that determines the elasticity demand, whether it's more or less elastic. It's a time period. The idea here is that the shorter the time period, the less elastic demand is, the longer the time period, the more elastic. And the reason, again, is the amount of substitutes that are available. right? So in the short run, the idea here, the example I give here, and one we usually do, is for petrol. Right? So imagine the price of petrol doubles, which, by the way, is what happened in the 70s, and the Israeli-Palestinian war in 1973. I think prices tripled, and then in 1979, with the Iran crisis, they doubled. Right. So how would you respond to that huge increase in the price of petrol? Well, in the short run, you're sort of stuck because you have your car already, right? So, and you needed to get to work. At least back in the 70s, most people would drive. So you needed your car to get to work, so you're stuck. You had to pay the higher prices for petrol. There was very little change in the quantity demanded. Now, there will be some change. Maybe on the weekends you don't drive as much, so on and so forth, or you drive more carefully to conserve on fuel. Right? But in the short run, it's hard to substitute out to something else because your car runs petrol. But in the long run, there are a lot more substitutes available. That is a lot more choices for you to choose in the long run than in the short run. So if you can think, if you had, say, an SUV that uses a lot of petrol, then when it comes time to buy another car in a couple of years, then maybe you replace the SUV with a more a car that had better fuel economy. Or you may say have car sharing, carpooling. Or you may decide, for example, to ditch a car altogether and take public transportation or buy a bike. Usually these things take a little bit of time before these decisions are made or can be made. So most people don't, if the price of petrol doubles, they don't just rush out, sell their SUV the next day and buy a more economical car. They usually wait until it's time to buy another car again. Right, so that's the idea. The longer the time period, the more elastic demand tends to be. We tend to see that. So one of the things we want to talk about, therefore, is what's the time period of your demand? Because remember, at the very first lecture we talked about this. Is that when we talk about the consumed, we should be talking about over what time period. As I said, 1 apple a year is a lot different from 1 apple a day. So here we can see what matters for elasticity demand. And the third one is definition of market. Again, it has to do with the notion of close substitutes, right? If I tell you the what's the elasticity demand for food, well, it's going to be relatively low, right? If the price of food goes up, well, you still need food, right? So the quantity demand of food doesn't go down that much. Now you can eat a little bit less, but you still need to have food. So the price elasticity demand for food overall is quite low. But that's a very broad definition of a market. If you pick something much more specific, for example, the prices of breakfast cereals, right, that would be more elastic, because if breakfast cereals go up in price, then you can say, well, I'm going to substitute to, say, having muffins or crumpets or something else like that, or eggs and bacon. Right, and then so that would be more price elastic than food, breakfast cereals. And then even within breakfast cereals, for example, Sultana brand would be more price elastic than breakfast cereal, because there's all the other breakfast cereals you could substitute from Sultana brand. So if Sultana brand goes up in price, you say, I'm not going to buy that anymore. Now I'm going to buy cornflakes or Rice Krispies or whatever. All right. So the narrower the definition, the more elastic demand tends to be as well. All right. That's just the notion again. There's more substitutes to narrow the definition. All right, so that gives you an idea of the price elasticity demand determinants. I just want to show you now some studies to give you a feel for the applications of price elasticity demand. Okay. All right, so the first one is from the UK Revenue and Customs Service, and they're estimating the price elasticity demand for alcohol products. So here's what they find. Right, you see the average price elasticity demand for the beer, wine, and spirits. Right, and by the way, notice here that they leave the minus sign in, that we would take them out. But the price elasticity demand for beer, wine, and spirits, notice it's all less than 1. Right, so these are all inelastic demands. All the alcohol here are inelastic demand. Why does that matter for the revenue and customs? Right. Well, the idea is that you want to tax inelastic demand. Why? Imagine what happens with inelastic demand. We talked about this last Monday. if demand is inelastic, then when you raise your price, say 10%, quantity demand is going to go down by less than 10%. So, for example, for beer, if you raise beer prices 10%, then the quantity demand is only going to fall by 4.4%. So why does that matter? Well, if it's inelastic demand, then we know the revenues will go up when the price rises, right? So what happens here for revenue and customs? Well, they tax alcohol, and a tax on alcohol, as we're going to see later on in the course, will raise the price of alcohol. But because it's inelastic demand, the quantity demand won't fall very much, and therefore revenues will increase more. Revenues for UK revenue in custom will rise more than for elastic demand. That is, their tax revenues will be higher than if they tax that elastic good. Because if they tax an elastic good, the rise in price will cause the demand to fall by a greater percentage, and therefore you won't be taxing as many units of goods, and your revenues won't be as much. So this is why governments that are taxing goods are very concerned about price elasticity demand. You want to tax an inelastic good like alcohol. And the same thing here, this is the World Health Organization's estimate of tobacco price elasticity demand. Again, you can see for all these countries, it's inelastic demand. So again, it's not a surprise that governments tax tobacco. It raises more revenues than if you tax a good that's more elastic. Okay. The last one is one I have for a while now, but it's pretty dated, as you can see, from 1970 in the US, so it's 50 years old. But again, the same idea. So back in the 1970, this was before those oil crises in 1973, 1979. So everybody drove a very fuel inefficient vehicle, big V8, 20 feet long or whatever. And you can see that the petrol, which in North America we call gasoline, petrol price elasticity demand was very, very low, very inelastic, right? So that's saying that the prices of petrol goes up by 10%, then demand was only going to fall by 1.4%, right? So that's very, very insensitive to changes in the price back then. By the way, notice again here, for this study, they actually dropped all the minus signs, right? So it's easy to pick up. And then you can see the tobacco, inelastic, alcohol was inelastic, although there it's actually quite close to 1. Right, whereas restaurant meals are very elastic here, right? And you can see why. There are very close substitutes for restaurant meals, and that's home-cooked meals or meals that you can get from the supermarket, right? So the idea here is that if restaurant prices go up significantly, then you can just say, "Oh, I'll stay home and eat instead." Right? So it tends to be price elastic. Okay. And here's the study that shows a distinction between short-run and long-run elasticity demand for petrol. Right, so this is from 2008 from The Economist. And it says the study showed that a 10% rise in petrol prices reduces the petrol demand by 3% in the short run and about 7% in the long run. So convert that to elasticity, that's saying that the elasticity demand in the short run is 0.3 and the elasticity demand in the long run is 0.7. So again, as we said, the elasticity demand is more elastic in the long run than the short run. I will point out, notice here, by the way, that even in the long run, it's still inelastic. It's less than 1, right, 0.7. But we're just saying it's more elastic than in the short run. So just be careful about that distinction. Okay. All right, so the second elasticity we want to look at for demand is the income elasticity demand. The price elasticity demand is probably the most important one, which is why when we say elasticity demand, we mean the price elasticity demand, and we mean the own price, that is the price of the good. But the second most important one is probably the income elasticity demand. Now, I'm using the Greek letter eta here, or eta, for income elasticity demand. That's common but not universal. So if you see a different textbook use a different number, a different letter, that's not abnormal. So just go with it. All right. So where is the price elasticity demand? Was the percentage change in quantity demanded from a percentage change in the price? The income elasticity demand is percentage change in quantity demanded from a percentage change in the income. Right? So how can we talk about this? Well, we already know that for inferior goods, the change in quantity demand from the change in income is negative, right? If you make more money, you tend to consume less of these goods. These tend to be lower quality goods, right? So that means the income elasticity demand is going to be negative. And likewise for normal goods, as your income goes up, you consume more of it. So we can see that the income elasticity demand is going to be positive. All right. By the way, sometimes you see that normal goods are split into two types. A necessity good is where the income elasticity is positive, so it's normal, but it's less than 1. What is that telling you? That's telling you that when the percentage change in quantity demanded is less than the percentage change in income, right? So if your income goes up by 10%, this is a normal good, so your quantity demanded goes up, but it goes up by less than 10%, right? So this is typical for necessity goods like food. So if you look at the data, you'll see that as people become richer, they consume more food. Now, be careful about that. Obviously, like rich people don't necessarily eat more than poor people, right? High-income people don't tend to eat more than low-income people, for example, in absolute quantity. But remember, we talked about this before. We do quality adjustments, and when you do a quality adjustment, then rich people consume more food than poor people, right? Because they switch. High-income people tend to have more higher quality foods, right? They eat more out in high-end restaurants. They shop in more high-end supermarkets and so on and so forth. More, instead of just regular table salt, they will have Himalayan pink rock salt or something like that, right? So on a quality adjusted basis, high-income people tend to consume more food than low-income people, right? So it's a normal good. However, the increase in expenditure of or consumption of food as you become richer doesn't increase as fast as your income increases. So what we see in the data, therefore, is you'll see that for low-income people, food makes up a larger percentage of your budget than for high-income people, right? So for low-income people, say it's 40% of your budget, and for high-income people, it might only be 20 or 30% of the budget or less, right? So, for example, suppose you make $40,000 and you spend 20,000 on food. So 50%. No, that example I want to do is suppose you make $50,000 and you spend $20,000 on food, right? So you're spending 40% of your budget spent on food, right? 20,000 over 50,000. Now imagine that your income doubles. Now you make 100,000, but that's 100% increase in your income. But imagine your consumption of food only increases by 50%. So instead of spending 20,000, now you spend 30,000 on food. So it's a normal good. As your income went up, you spend more of it. But now notice it's only 30% of your budget, right? So that's the idea for necessity goods. The normal goods, you buy more of it as you get richer, but it becomes a smaller share of your budget. Conversely, luxury goods are normal goods where the elasticity is greater than 1. Right? Now, we're going to see an example on a future slide here that says air travel was income inelastic. That was in 1970. You're going to see modern data that says air travel actually is income elastic. And in fact, it's greater than 1. So we would call that a luxury good. We'll see some other examples of luxury goods coming up, but you can just think of things that you buy as your income goes up, that grow at a greater percentage than your income. And these are typically things like, luxury. So, buying boats, for example. So we'll see during expansions, good times in the economy, sales of boats will increase at a faster percentage than the increase in incomes for consumers. So, consumer income may increase by 10, 20, 30% or whatever, but boat sales would increase by 50 or 60, 100%, for example, during expansion. Right? So that's typically type of thing you see in the data. Now, of course, conversely, that means during the recession, when incomes are falling 10, 20% or whatever, then luxury goods are going to fall by a greater percentage, right? So good times are very good for luxury goods, but bad times, the recessions are very bad for luxury goods. They're much more sensitive to income changes. And notice, by the way, unlike the price elasticity demand, the signing elasticity is important, right? If it's positive, it's a normal good. If it's negative, it's an inferior good. So that's a way of telling which is which. All right, here's some estimates again. So this is, again, the World Health Organization. This is the income elasticity demand for tobacco. And you can see that they're all positive. So tobacco is a normal good, right? That as countries get richer, they consume more tobacco. Now, again, it's probably not the case that they're smoking more, per se, for most people. It's more the case that they're switching from low-quality tobacco to high-quality tobacco. So on a quality-adjusted basis, they're consuming more tobacco. Right, that's my guess. And note, by the way, for every country in that list, except for Egypt, tobacco is a necessity. But in Egypt, it seems to be a luxury there, if you trust that data. Okay. All right, here's some estimates of income elasticity demand, but back from 1970 in the U.S. So as I pointed out, it said that oh, it's not on here. Okay. All right, so you can see in 1970, alcohol was considered a luxury good, that it was very sensitive to income. Again, it's not so much that high-income people drink more than low-income people. It's that they, on the quality-adjusted basis, right, they tend to drink higher quality whiskeys and so on and so forth, getting Scotch from Scotland. So on a quality-adjusted basis, they're actually consuming more. So that's probably what's going on. You can see housing is income elastic as well. So that's very sensitive. So the housing industry would be sensitive to whether or not the economy is in a recession or a boom. By the way, somewhat alarming, back in 1970, you can see dental services considered a luxury. So I guess it's kind of thing that during the expansion phase, you have extra income, and then you can go to the dentist and take care of your teeth then. But during recessions, hard times, that's one of the things that you give up, and you say, "Hey, I'll just have to wait until the good times come back again." But again, it's a bit alarming. On the other end, look at the two at the bottom there for margarine and flour. Notice the negative sign in front of the income elasticity. So that's telling you these are inferior goods, right? The rest are normal goods. So ask yourself, to get a feel for this, why is margarine and flour inferior goods here? And can you come up with an explanation? Now, the first one for margarine is pretty straightforward. Hopefully you thought about this. If not, pause and think it over, and I'm going to take a sip of my coffee. Okay, so why is margarine an inferior good? Well, the idea here is that margarine is considered a lower quality version of butter, right? And it tends to be cheaper. So if you're a low-income person, right, you're tight on the budget, so you would like to have butter, but you can't afford it, so you buy margarine instead. But as your income goes up, right, now you have extra money to spend, and you say, well, I actually like butter better, and now I can afford it, so I'm going to switch from margarine to butter. I'm going to substitute butter for margarine. So as you become richer, the quantity demanded margarine will go down, right? So that's why it's an inferior good there. What about flour? Flour is a slightly more trickier one. Why do you think flour is an inferior good? Because on your face of it, you think it's kind of odd. If you have a recipe for bread or for a cake or something, and it calls for flour, right, you're not going to substitute something else in there for the most part, right? It's hard to think of what are you going to put in instead of flour. You say, well, sugar looks like flour. I'll put sugar in instead of the flour. That's not going to work out very well. Your kids might like it, but that's not going to do very well. All right, so why is it the flour is an inferior good? Well, here's my guess. Well, look at the date in 1970. So back then, it was mostly women still doing the cooking. Right? And imagine at that time, a lot of them would cook from scratch. So they would make their own bread, which so you need flour for bread, and they would make their own cakes, so you need flour for cakes, and most of the other recipes that they use, that you want to coat your sugar with flour and eggs and so on. So coat your chicken with flour and egg, for example, you need flour for that as well. So there'll be demand for flour, but what happens is as you become richer, then you say, well, my time becomes more valuable. I don't have time to make meals from scratch anymore. So what happens? Well, people go to the supermarket and they buy processed food. That is, they'll buy a cake ready-made, or they'll buy a bread from a bakery already made instead of making it from scratch. Or they'll actually go out and eat at a restaurant more often. You saw earlier here that restaurant meals, you can see, is a luxury good. As our income goes up, we consume a greater percentage of our budget on restaurant meals. So by doing that, by having more restaurant meals and more processed meals from supermarkets, and less meals from scratch, then the demand for flour will go down at home because we're not making the meals from scratch anymore. So that's what I suspect is going on in 1970, that the demand for flour goes down as our incomes go up. And here's the last one here. For those who don't know, Walmart is a value department store, so it tends to have low prices, and you can think of it generally lower quality goods. Not necessarily it's bad quality, but it's not considered the highest end quality. Right, so you get a good value for your money. Not necessarily the brand names that you may be used to, but off brand, but much cheaper. Right, so had a study here on the income elasticity demand for Walmart, and they found that the income elasticity demand for Walmart was approximately roughly about minus 0.7. So again, negatives telling you it's an inferior good, right? That low income people tend to shop at Walmart, but as you become richer, higher income people shop less at Walmart. What's going on? The same old story I told you about for inferior goods. As you become richer, you tend to switch from low quality goods to higher quality goods. So here you tend to switch from shopping at a value department store like Walmart to shopping at a more high-end department store, say like David Jones here in Melbourne. Okay, so that's what I suspect is going on here. Now that the word inferior obviously has a negative connotation, and it sounds bad here that Walmart's an inferior good, right? But one of the things about Walmart is, as a stock, it can be a darling for stock investors, and let me just explain why. And so, one of the problems you'll see if you ever get into investing in stocks is that stocks tend to all move together, right? So, during the expansion years, when good times are here, the economy's growing quickly, stocks tend to all go up together, right? The stock market rises with the economy. So, you buy one stock or the other, they all tend to go up together. Right, which is great. However, during the recession, when incomes are falling, the economy, people are getting laid off, then stocks all tend to be falling together. So that's a problem because you want to get out of falling stocks, obviously. You don't want to lose money. So you take your money out of a falling stock, but it's hard to find other stocks to invest in because most of them are falling at the same time. They tend to move together. However, you can see Walmart would probably be an exception to this. Like what happens in Walmart? Well, when a recession comes, incomes go down, people start tightening the budget, and now instead of shopping at high-end department stores, they decide to start now shopping more again at Walmart because their incomes have gone down. So Walmart could actually do better at a recession. They'll get more customers, more quantity demanded as incomes go down. That is during recessions. Right? That's what the income elasticity demand is telling you. So in that sense, this could be a nice stock to have during a recession, right? Well, all the other stocks are falling in value. Walmart, potentially at least, could be going up in value. So that's why it's often a bit of a darling for stock investors. Okay, the last elasticity demand I want to look at is the cross-price elasticity demand. And this is the percentage change in the quantity demanded of one good, X, divided by the percentage change in the price of another good, Y. Right? And we know how to talk about the sign of the cross-price elasticity demand. Remember that if X is a complement of Y, then when the price of Y goes up, the demand for X will go down. Right? They tend to be consumed together. So price of Y goes up, you consume less Y, and therefore you also consume less X. Right? So the elasticity demand so the cost price elasticity demand will be negative. And conversely, if X is a substitute for Y, we know that as the price of Y goes up, right, then the demand for X goes up, right? So Pepsi rises in price. We consume less Pepsi. Instead, we buy Coca-Cola instead, so the demand for Coke goes up. So in that case, the cost price elasticity demand would be positive. So again, note that the sign of the cost price elasticity matters here, right? Negative for complements, positive for substitutes. And here are some examples. Right, so here from 1970, this was 1977. In yellow there, I show you two cost price elasticity demand. Notice that those are different cost price elasticity demand. The first one on the top row, right, that's the cost price elasticity demand showing you the percentage change in the quantity demanded of beef divided by the percentage change in the price of pork, right? And that equals 0.28. So if the price of pork goes up by 10%, we see that the quantity demanded of beef goes up by 2.8%, right? So the substitutes. That is, beef is a substitute for pork. All right. The second row, however, right, tells you whether or not pork is a substitute for or a complement for beef, right? So the numerator in the cost price elasticity demand would be the percentage change in quantity demanded of pork, and the denominator would be the percentage change in the price of beef. So here is 0.14, so a 10% increase in the price of beef leads to an increase in demand of pork by 1.4%. Right. So notice you have different numbers. So I pointed this out before. If beef is a substitute for pork, doesn't mean you can say anything about whether pork is a substitute for beef or not. Right. In this case, it is. Right. They're both substitutes for each other, but don't assume it, right? Because they're measuring different things. Likewise, here, butter and margarine we talked about earlier are substitutes. We can say. Right. So it does tend to be the case of if X is a substitute for Y, Y tends to be a substitute for X, but it doesn't have to be the case. And I want to give you a nice illustration that I found this table in that same article from the UK Revenue and Customs. So here they did the cross price elasticities of the various types of alcohol with each other. The only thing I would note there is on and off means on premise and off premise. So on premise, you buy the alcohol at a pub or a restaurant or something, and off premise is you buy alcohol to take home, say from Dan Murphy's or something. Okay. Now notice that if you look at the table, most of the cross price elasticities are close to zero. Right. So there's not much sensitivity to changes in the price of other types of alcohol. Right. If the price of one alcohol. So, for example, let's take a look at beer on premise and beer off premise. So you can see it's 0.07. That's the first row, second column. It's 0.07. So if the price of beer off premise goes up by 10%, right, that doesn't affect much of the demand for beer on premise. That is, if the price of beer that you take home goes up by 10%, then your demand for beer at a restaurant or a pub doesn't change that much. It's not particularly sensitive to that. Okay, so that's true for most of the cost price elasticities, close to zero. The one exception is the next one over here. So look at the first row, third column, right? So this is beer on premises with spirits on premises, and notice it's 0.37, so that's pretty significantly high there, right? So what is this saying? This is saying that a 10% increase in the price of spirits at a pub or a restaurant causes the demand for beer on premises to go up by 3.7%, right? So fairly sensitive to the price of spirits, right? So that's cost price elasticity telling you that beer on premises is a substitute for spirits on premises. However, look at the other way around. Look at spirits now on the second row on premises and go across to beer on premises, which is the very first column, and you see it's minus 0.13, right? So this is saying the spirits on premises is a complement for beer on premises, right? That is, if beer goes up by 10%, the quantity demanded of spirits goes down by 1.3%. So there's an example I was telling you about that. Here, beer was a substitute for spirits, but spirits are a complement for beer, right? So it's unusual. I can actually find a particular study to show you that that directly, but there it is. So it's kind of neat. And by the way, along the diagonal axis, those are the home price elasticities. And you can see they're negative all the way down, right? The price of the good goes up, the quantity demanded goes down. Okay. All right, so that's the it for it for the elasticity of demand lectures. Hopefully you found that pretty straightforward. Tutorial 4, I'll give you some questions to work on elasticity demand, both interpretation and calculation. But what I want to do now is oops, I probably shouldn't have done that. Okay. What I want to do now is to do the lecture note of consumer surplus. Some tutorial questions have to do with consumer surplus, and I want to get it in before they break because this will be the end of the consumer side of the course, at least directly on the consumer side. So after the break, I want to switch gears and start talking about the producer side, right? So we want to look at the decision, the producer's problem, how the producer decides how much to produce. But we're going to look at that after the break. So this will be a natural way to finish up before the break, finish up the consumer side on consumer surplus. So let's do that today. All right. So what we're interested in a lot of times is there'll be a policy undertaken, and we want to know how does that affect consumers, right? So, for example, if there's a new Trans-Australia road, that would presumably lessen traffic, make it easier to drive across country, maybe shorten the time traveled because of less traffic, and it goes to more places that are convenient for you. So how much does that benefit consumers, right? Or, for example, suppose we put a tariff on imported steel. Now, tariff just means that it's a tax on an imported good, right? So we put a tariff, but a tax on steel, but it's only on imported steel. It's not on domestic steel, right? That's what a tariff means. So what happens there to consumers? Well, we know it's going to hurt consumers. Well, we're going to see later on, by the way, that if you put a tax on a good, typically what's going to happen is the price of the good is going to rise. So you're paying more for the good. So that's going to hurt the consumer, as we're going to see. The question is, how much does it hurt the consumer? So a lot of this analysis, when we do policy analysis, and we want to see how there's a consumer benefit or hurt from this policy, what we're going to look at is how does the price change for a particular good from this policy, and how does the quantity demanded change? And we're going to use that to measure the change in utility for that consumer to say whether they're better off or worse off. That we can know from theory, but how much better off or how much worse off, this is a measure that we're going to use called consumer surplus to actually measure how much better off or how much worse off we are from a change in policy. Okay. All right, so we're going to do an unusual case to start with, where demand is discrete, right? Only fixed units. You can buy one unit of the good, or 2 units of the good, or 3, but you can't buy 1.2 or 1.8 or whatever, right? And utility is going to have the special functional form, but you've actually seen this in the tutorials, and that functional form is quasi-linear utility. So that quasi consumer that we've had in the tutorials, quasi had the quasi-linear utility function, at least one example of it, as we'll see. Okay, so I'm going to do the special utility function. The consumer is going to assume to have that kind of taste, and we're going to assume discrete demand, and we're going to put it together, and we're going to come up with a measure how much better or how much worse a consumer is when the price or quantity demanded changes for a particular good. And then we're going to extrapolate that to the general case for other utility functions and non-discrete demand. All right, to start off with, we're going to say we want to highlight when we talk about consumer surplus, we're going to talk about a particular market for, the market for good X, right? So we're just going to look at one good and say, well, what's how do we measure the benefit or the cost to the consumer of a policy change that changes the price of good X or changes the quantity demanded of good X, right? So we just want to highlight good X. So that way, what we're going to do is we're going to treat all the other goods, right? Well, we'll see what we're going to do how we're going to treat all the other goods in a second, right? We're going to let P be the price of good X. I'm not going to put a subscript PX, as you're going to see in a second why I'm not going to do that. We're going to call the price of X P. So therefore, the expenditure in good X is P times X. Right? If you buy X units of X, then the expenditure is P times X. You have income of M. That means you have M minus PX left over in income to enable you to spend on other goods. Now let's define the expenditure on all of the goods to be Y. So therefore, Y is equal to your remaining income after your expenditure on good X. So it's M minus PX. Right. Now let's rearrange that. Bring the PX from the right-hand side to the left-hand side, and we just get a standard-looking budget line. PX plus Y is equal to M. Right. Now the first term on the left-hand side, that's your expenditure on good X. The second term is expenditure on all other goods. But notice it looks like just like a regular budget line where we have two goods, X and Y, right? And the total expenditure is equal to income. So we can think of the same thing here. Is we can think of Y as being a good. Now it's all the other goods, but we're just taking all the other goods and calling it one good. Since all we're interested in is looking in the market for X. So we're treating all the other goods as just one good. And notice that the price of Y is just one. There's a one is a coefficient in front of Y. So we can think as the price of Y being one here and Y being a good. Okay? So that's a neat little trick when you're just interested in looking at one market, right? Remember, we do ceteris paribus, everything else is held the same. So we're not changing the prices of any of the goods or the quantities of any of the goods. We're just going to hold it fixed. Okay? So that's what we're going to do there. All right, so what's the quasi-linear utility function look like, right? The idea here is that with quasi-linear utility, your utility from the good X is independent of your utility from other goods, right? This is the case for a lot of things, right? When you buy, breakfast cereal, we've been talking about earlier, if you buy some Sultana brand, your utility from Sultana brand is probably pretty independent of your utility from petrol, your utility from watching a movie, your utility from reading a book, so on and so forth, right? So for the most part, it's going to be independent of other goods. Perhaps it's not independent of your utility from consuming milk, if you only have milk with your cereal. But in general, it's a pretty reasonable thing to do for a lot of goods, that utility from that particular good doesn't depend upon the amount that you have with the other goods. Okay. So if that's the case, then we can separate out utility from X and utility from Y. Okay. So what we have here is we have the first term on the utility function of the bundle XY is we just take the utility from good X, call that Vx, right? Where the derivative is positive, so more X is preferred to less X. And in the second term, we have the utility from Y, but we're just going to define it to be Y. Remember, the actual utility number we give doesn't really matter, right? Because we can always add or subtract or multiply or square that utility and still represent people's preferences. So we're just going to say utility from good Y is just Y, right? We could have made it Y squared, or we could have made it 10Y or whatever. It doesn't really matter that much. But we're going to make it Y for convenience. All right, so we separated our utility from X and utility from Y. But notice that both goods, more is better, right? If Y goes up, U goes up, and if X goes up, V goes up because the first derivative is positive on V. All right, so we have monotonicity satisfied. You're gonna consume on your budget as normal. So it's a relatively normal looking utility function in that sense. Okay, but that's a quasi-linear utility. We can separate out the utility from X from the utility from Y there, and utility from Y is just going to be Y. Okay, so the examples I give here, the example 2 is one I actually did in the tutorial, right, where utility of the bundle XY is just equal to ln of X plus Y. Y is, just check, remember, what's the derivative of ln of X? Remember, it's just 1 over X, right? Well, X is a positive number, so that's greater than 0. 1 over x is greater than 0. So the derivative is indeed positive. So that is indeed a quasi-linear utility function. Likewise, for the first one, we have the utility of the bundle xy is equal to the square root of x plus y. Again, the derivative of the square root of x is positive, right? Differentiate it using the power rule, you get 1/2 x to the minus 1/2, which is 1 over 2 times the square root of x, which is a positive number. All right, so these are both quasi-linear functional forms. What do they tend to look like? Well, I guess it's on the next slide after that. I forgot to mention this. So what's the implications of having quasi-linear utility? Well, one thing is what the margin rate of substitution looks like. Right? Remember, margin rate of substitution is defined to be the ratio of the margin utility. So we take the margin utility of x divided by margin utility of y. But the margin utility of x, right, it's just v prime x. And what's the margin utility of y? We'll take a look at the utility function, differential utility with respect to y, right? And it's just 1, because the coefficient in front of y is just 1. So therefore, the margin rate of substitution is just equal to v prime x. Okay, so what does that tell us about the slope of the quasi-linear indifference curves? Well, remember, the slope of the indifference curve is the negative of the margin rate of substitution, so it's just minus v prime x. Okay, so what does that tell us? Well, if x is constant, if we keep x at the same level, say x equals 10, then the slope of the indifference curve is unchanged no matter what the value of y is. So every bundle with x equals 10, say x equals 10 and y equals 10, or x equals 10 and y equals 20, or x equals 10 and y equals 10 billion, right? Doesn't matter. All of those bundles will have the same slope of the indifference curve at that bundle, right? So here's what it's going to look at. So here's an example of a quasi-linear indifference curve, right? And what we're saying is pick a particular x. So I picked x star here, looks to be about 9. And we'll say, well, let's look at all the bundles x, y, where x is equal to 9. So that's just going to be the vertical line up from x equals 9. Just the vertical line would be all the bundles that have x equals 9. And what we're saying for quasi-linear utility, if you take the slope of those bundles of the indifference curve, take the slope of the indifference curve at each of those bundles, they'll all be the same. Right? So that's what this is saying here. You can see for x equals, say, 9 and y equals 1, you're in indifference curve 1. You can see that slope is the same as if you had x equals 9 and y equals 2, or x equals y and y equals 3, and so on and so forth. They all have the same slope for the same value of x. Okay, so we're going to make use of that. The second implication about quasi-linear utility is that it doesn't depend upon income. And let's see that. All right, so what happens to the budget line as you increase income? Well, we know what happens, right? So here's our budget line. We increase income, right? The slope of the budget line is unchanged because we haven't changed the relative prices. It's still px over py. Remember, we're just using p for px. The price of y, remember, is 1. So the slope of px over py, that should be a minus px over py. Never noticed that before. Px over py is equal to p. So the slope is minus px over py, which is minus p. So we haven't changed the price when the income goes up. So the slope hasn't changed. That means that we're just shifting out the budget line parallel to the old budget line. We've done this before. All right? So there's no change, just a parallel shift. But what does that mean? Right, that means, therefore, just ahead, next thing. Now we say, okay, we want to solve the consumer's problem. We know the solution to consumer's problem is where the slope of the indifference curve is equal to the slope of the budget line, that tangency condition. Okay, but we see here, if income goes up, right, the slope of the budget line has not changed, right? So therefore, whatever was the solution originally, right, whatever that slope was, still has to be the solution today for the new income. That is, right, originally we took the original quantity demanded as x, the original optimal bundle. We determined what the slope of the indifference curve is equal to the slope of the original budget line. And now we say, okay, let's increase income and find a new optimal bundle. Well, the slope of the budget line hasn't changed, right? Still minus p. And that means that the optimal solution, the slope of the indifference curve, hasn't changed. But if the slope of the indifference curve hasn't changed, then we know we're at the same x, as we showed on the previous slide, right? At the same x, no matter what the value of y is, the slope of the indifference curve is always the same, all right? So we can conclude, therefore, with quasi-linear preferences that X is the quantity demanded at one level, it would be the quantity demanded at every income level. As we increase income, right, the slope of the budget line doesn't change, and therefore the slope of the indifference curve at the optimal bundle doesn't change, which means that we're at the same X. Okay, so the conclusion, therefore, as income goes up, the quantity demanded does not change. Right? In other words, we have no change in quantity demand when income goes up. Okay. Now, it's hard to think of exact examples where you never change your quantity demand as your income goes up, right? But as approximations, right, what's going to be an example where your quantity demand doesn't change very much as your income goes up? Well, what goods would you say if you got richer, you wouldn't change your quantity demand very much? Well, we can look at income elasticity demand to get a feel for this, right? If the income elasticity demand is close to zero, that says, the percentage change in quantity demanded is quite small from the percentage change in income, right? So again, it's not going to be very sensitive. So change in quantity demand is going to be quite small, right? So what are income elasticity close to zero? Well, for normal goods, those are what we call necessities. Remember, for necessities, the normal goods with income elasticity between 0 and 1. Right? So you would look for necessities that typically have a very small change in quantity demanded from a change in income. Right? So example might be food. Right? If your income goes up, as we pointed out, you do tend to spend more on food. Quantity demand does go up, but it goes up a smaller percentage than your income. So that might be a rough approximation. So think of most necessities like that. The example I used to use for years and years was salt. Right, that no matter how rich or poor you were, you pretty much use the same amount of salt. Now I have to adjust that. As I mentioned before, on a quality adjusted basis, it's probably the case that high income people are consuming more salt on a quality adjusted basis, because now they're starting to consume things, like I said, Himalayan pink rock salt or whatever. So that example is not as good as it used to be. But that's the idea. The things that you think about if you, in your own personal experience, that if you got richer, you wouldn't use that much more, maybe tissue paper or something like that. But even those, most goods you can think of, high income people tend to switch from lower quality versions of the good to a higher quality version. So they might use much softer tissue paper than low income people. But that's the general idea. Necessities tend to be relatively small changes in quantity demanded. Okay. All right. So that's the first part, quasi-linear utility. And we're going to come back to that in a second. The second part we're going to do is say that goods can only be consumed in discrete amounts. So we're going to make the whole numbers. You can buy 1 unit of the good, 2 units, or 3 units, and so on and so forth. So no fractional amounts. All right. First, we want to define what a reservation price is. All right. We define the reservation price for the first unit of the good, X, is the price such that you're just indifferent between consuming 1 unit of good or none at all, right? So you can think of it, the price is so high, you say, no thanks, it's too expensive. And the price keeps coming down and down and down. You say it's too expensive. And then it hits the point where you just say, oh, okay, now I don't care whether I buy 1 unit of good or don't buy any. I'm indifferent. It's just a level of that price. So we call that price for the first unit, we call that the reservation price for the first unit, and we denote it by R subscript 1, all right? So what does that mean, therefore, if the consumer is indifferent between consuming 0 units of the good or 1 unit of the good? That means the utility number that we assign to those two bundles has to be the same. But what are those two bundles? Well, on the left-hand side, you can see, if you're consuming 0 units of X, right, then how much Y are you consuming? Well, if you're consuming 0 units of X, then you have all your income left over, M, to spend on good Y. But remember, good Y has a price of 1. So how much of good Y can you buy? You can buy M units of good Y. So if you buy 0 units of good X, you can buy M units of good Y. Likewise, on the right-hand side, we have the bundle, we have this bundle where you consume 1 unit of X. If you buy 1 unit of X, you just spend P dollars on it, right? And that leaves you with M minus P dollars to spend on good Y. Good Y costs $1, so you can buy M minus P units of good Y. right? Now that price, that P, is determined just exactly such that these two bundles you're indifferent to, and therefore they have the same utility number, right? So that price, we call that price R subscript 1, the reservation price of the first unit, all right? So when the price of X is equal to R1, then the consumer is indifferent between consuming these two bundles, okay? And as I pointed out, as the price is higher, then you're no longer indifferent. You say, no thanks, I get higher utility by consuming no X and M units of Y, so I'll buy no X, okay? As an alternative, we often call the reservation price the maximum willingness to pay. And you can see why, therefore, right? If the price is greater than R1, you won't buy any. So the maximum you want to pay for that first unit is R1. All right, so it's just another name for it. Okay, so what we did that for the first unit. We can also do this for future units. So what is the reservation price for the second unit? That is, what is the price such that you'd be indifferent between buying one unit of good or two units of good? Right? Now remember, demand slopes down, so this price has to be less than R1, the maximum willingness to pay for the first unit. Right? So you have the first unit, right? The price came down to R1. Now you say, I'm just willing to buy one unit. Now the price starts falling. So I call that price the definition price in second unit. So we would represent it like this. The two bundles on the left-hand side, we have the bundle where you buy one unit of the first good, which leaves you enough income to buy M minus R2, M minus P of the second unit. And on the right-hand side, you buy two units of good X. If you buy two units of good X, you just spent 2P. That leaves you with M minus 2P of expenditures that you could buy of good Y. So R2 is the price of good X such that these two bundles you're indifferent to, that is, they have the same utility number that is they're equal to. All right, so that's how we determine R2. So what would that price be? As I pointed out, it's got to be less than R1, right? Because of the downward sloping demand curve. The lower the price, the higher the quantity demanded. Right? And we can see, therefore, what we have here is if the price is greater than R1, you buy nothing. If the price is equal to R1, you're indifferent between 0 and 1 unit. If the price falls below R1, you prefer to buy 1 unit than 0. And then if it hits R2, now you're indifferent between buying 1 unit and 2 units. Right? And then you can do that so on and so forth. So if the price now is between the range R2 and R3, then you'll buy 2 units. If it's between R3 and R4, you'll buy 3 units, and so on and so forth. All right, so what is the demand curve going to look like? All right, so on the vertical axis, we have the prices. So we'll put in R1, the prices R1, R2, R3, and R4. We know if the price is greater than R1, quantity demanded of X is 0. So it's just going to be, demand curve would be that part of the segment of the vertical axis. And then when the price of good X is equal to R1, then you're indifferent between 0 units and 1 unit of good X. So what happens is you're going to have a jump in the demand curve. It's not going to be continuous, right? It's going to jump from the vertical axis at 0, Q equals 0, to Q equals 1. Remember, there's no fractional amounts in between that you can buy. And then if the price falls from below R1, right, you'll buy 1 unit until you hit the price of R2, where you're indifferent between buying 1 unit and 2. So you have another jump in demand, and then continue on like that. So this is what it's going to look like, right? The discontinuity in demand function. So that dotted line, the horizontal dotted line, that's not part of the demand curve, right? You can't actually consume fractional components. It's a discrete demand curve. So it's just jumping from discrete components, jumping from one vertical segment to another vertical segment down the demand curve. All right. Now I wrote the demand function for X here. You can see X is equal to N when the price of good X is between the reservation price Rn and the reservation price Rn plus 1. Right. So we said, for example, if if N is equal to 1, so quantity demand is equal to 1 when the price is between R1 and R2. Because you can see that on the diagram here. When the price is between R1 and R2, you can see that quantity demanded is 1. When the price is between R2 and R3, you can see the quantity demanded is 2. Prices between R3 and R4, quantity demanded is 3, and so on and so forth. And then, of course, if the price is greater than R1, quantity demanded is 0. All right, so that represents that demand function. So it's discrete demand, so it's not continuous because we can't consume fractional components of X here. All right, so now what we want to do is put these two together and derive our measure of the net benefit to consumers, what we call net consumer surplus. Okay. Now, to ease analysis, we're going to let the utility of consuming 0 units of X be 0. Now, again, remember, we can add or subtract any number or multiply any positive number or square or cube a number or whatever, and it doesn't affect the consumer's preferences. It doesn't change in the analysis. So just for ease of convenience, we're going to make the utility of consuming 0 units of X equal to 0. So it doesn't change anything. It's just more convenient. All right. Again, remember, R1 is the reservation price of the first unit. That is the price such that price of good X such that you're indifferent between consuming 0 units of X and 1 unit of X. Okay. What we're going to do, therefore, is we're going to substitute the quasi-linear utility function for U of X. Right. So for the bundle 0M, right, what's the utility of that if you have quasi-linear utility? Well, it'd be V of 0 plus M. Right. And then on the right-hand side, we have utility of when you consume 1 unit of good X and M minus R1 units of good Y. What's the utility of that? Well, utility of 1 unit of good X is V1, and utility of M minus R1 units of good Y is just M minus R1. So now notice, right, that R1, remember the reservation price is set such that those two utilities are equal to each other. So we set them equal. Notice that the M's on both sides of the equation cancel out, and V naught, V of 0, is equal to 0. So the left-hand side is just 0, and the right-hand side we have V1 minus R1. Bring the R1 to the left-hand side. So we see that the utility of consuming 1 unit of good X is equal to the reservation price of good X. So I will point out what's very unusual about this from a economist's point of view is, the problem with utility functions that we use in economics is that they're not observable. I don't know what your utility function looks like. I only get to observe your data, the prices, quantities that you choose, right? But here, with quasi-linear utility in this discrete case, notice that the utility is equal to an observable, at least in principle, that is your reservation price. I can observe different prices and then see what the price is such that you're just indifferent, right? If the price is higher, you buy nothing. If the price is lower, you buy 1. And I can say, well, there you go. There's your reservation price. And now I know your utility consuming 1 unit of good X. Right? So that's why this quasi-linear utility is very unusual and could be very useful for us. All right, so the utility consuming 1 unit of X is equal to R1. What about consuming 2 units of X? What's the utility of consuming 2 units of X? Well, let's do the same idea here. We're going to compare the bundle where you consume 1 unit of X with the bundle where you consume 2 units of X. The R2 is the price of X such that you're just indifferent between those two bundles. So the utility numbers are the same. So we set them equal. We replace the utility of those bundles in terms of quasi-linear utility. So the left-hand side, utility of 1 unit of good X is V1. The utility of consuming M minus R2 units of good Y is M minus R2. And then on the right-hand side, we have utility consuming 2 units of good X is V2. And utility of consuming M minus 2R2 units of good Y is M minus 2R2. Again, notice that the M on both sides cancel out of the equality. And then we take the minus 2R2 from the right-hand side, move to the left-hand side, it becomes plus R2. And then note that V1, we found in the previous slide, your utility of consuming 1 unit of the good was equal to R1, the reservation price of the first unit. So therefore, now on the left-hand side, we have R1 plus R2, and the right-hand side, we have V2. So we can conclude, therefore, the total utility consuming 2 units of good X is simply the sum of the reservation prices of the first 2 units, R1 plus R2. And then, as you can imagine, you can just keep on doing this. Total utility consuming 3 units, it's just R1 plus R2 plus R3, and so on and so forth. So that's very neat. All right, so let's apply this to our demand function. This is supposed to be, wasn't supposed to show that, but there it is. I was going to ask you, what is the area underneath the demand curve equal to when preferences are quasi-linear? So I've given you the answer. I didn't want to do that, but I forgot about this. All right, so let's take a look at the area underneath the demand curve up to 1 unit of good X, right? So what is that area underneath the demand curve from X equals 0 to X equals 1? Well, we see that it's just a rectangle. Area of the rectangle is the base times the height. The base is equal to 1, right, from 0 to 1. And the height, you can see, is equal to R1, the reservation price of good of unit 1. All right? So therefore, the base times the height is just equal to R1. But we know the reservation price is equal to utility of consuming 1 unit of good X. Right? So therefore, the area underneath the demand curve from X equals 0 to X equals 1 is equal to your utility consuming 1 unit of X. Right? Likewise, the area underneath the demand curve going from X equals 0 to X equals 2, the area underneath the demand curve is equal to utility consuming 2 units of X. We can see that the area underneath the demand curve is 2 rectangles. The first rectangle, remember, is R1, and you can see that the second rectangle, the area is equal to R2. The base is 1, right, from 1 to 2, and the height is equal to R2, so the area is R2. So the total area is R1 plus R2, but we showed that that was equal to your total utility of consuming 2 units of X. All right, so you can guess, therefore, what's happened here with the quasi-linear utility is that the area underneath the demand curve up to the amount that you consume is equal to your total utility of consuming that amount. Right? So if you consume 3 units of the good, then the total utility consuming 3 units of the good is the total area underneath the demand curve up to X equals 3, and so on and so forth. Okay. So just to summarize, when utility is quasi-linear, the area underneath the demand curve will be an exact measure of the utility consuming that many units of good X, so I call Q units here, right? So that's nice. Well, we're going to talk about, some policy change is going to change the price of X or change the quantity demand of X, usually both simultaneously. Then we're going to look at and see what the area underneath the demand curve is up to that quantity demanded, and we can tell what the exact measure of utility is for that consumer and see how that utility changed from the policy change and say how much better off or how much worse off that consumer is. Right? Now, as pointed out, most times, utility is not going to be quasi-linear necessarily, probably not. That is, most goods have some kind of, do depend upon income, right, at least to a small extent. Right? So when income goes up, we do change the quantity demanded for the good. So utility is not quasi-linear. So when utility is not quasi-linear, then it's not going to be an exact measure. The area underneath demand curve is not going to be an exact measure of the total utility consuming that many units of X, but it'll be an approximation. So the question becomes, how good of an approximation is that? Right? Well, it'd be a better approximation, right? The smaller the change in X is from a change in income. So it would be a pretty good approximation, as we pointed out before, for necessity goods. Right? For necessity goods, the income elasticity demand is positive, but less than 1. Right? So that's telling you that the quantity demand that doesn't change, it's not very responsive to changes in income. It does go up as income goes up. It doesn't go up as the same. It goes up by a smaller percentage as the change in income. So for necessity goods, perhaps that's a decent approximation to use the area underneath demand curve to represent the utility for that consumer of consuming that many units of the good. For luxury goods, perhaps that's not as good as approximation. Right, the income effect is too strong. I would suspect for housing, for example, tends to be a luxury good, and because it's such a large part of your budget, the income effect is quite large. Then this may not be a particularly good measure. But for most goods that you buy, say in the supermarket or at a department store, it's pretty reasonable that the income effect is relatively small. Right, that is, a change in the price of a shirt it's not going to have much of an income effect on you. Now, it will be the case that as you become richer, you do tend to buy higher quality clothes. So But again, they tend to be necessities. They won't change as great a percent as your income changes in general. Okay, so the question becomes, so we're going to use this as a measure of the benefit to consumer, is we're going to use the area need to demand curve. But just remember that, this is just an approximation for most cases, but it's going to be a good enough approximation for us. All right, so that lead up to talking about consumer surplus. And now I just want to go over the actual calculation of consumer surplus. And it's actually pretty simple to do, as we'll see. Now, we actually make a distinction between what we call gross consumer surplus and net consumer surplus. Now, it's net consumer surplus that we're going to use all the time. And in fact, when we call something consumer surplus, we mean net consumer surplus, not gross. But I want to start off with gross. So gross consumer surplus is that area underneath the demand curve from x equals 0 up to the number of units that you consume. We call that Q here. So from x equals 0 to x equals Q, area underneath the demand curve, that's what we're going to be the gross consumer surplus, right? That's our measure of the total utility you get from consuming X, right? If it's quasi-linear utility, it's the exact measure of the total utility. If it's not quasi-linear, it's just going to be an approximation. Okay. Remember, the reservation prices tell us the maximum willingness to pay, but if I go back here, just to notice that the reservation price, right, is the height of the demand curve, right? And for discrete cases, it's hard to see it, but if you had a continuous case in general, the reservation price of each fractional amount would be on the demand curve. So the height of the demand curve is the reservation price, which is your maximum willingness to pay. So when we talk about the area underneath demand curve, right, it's telling us the maximum willingness to pay for all Q units, right? The maximum willingness to pay for the first unit is R1, plus the maximum willingness to pay for the second unit is R2, all the way up to the maximum willingness to pay for the Qth unit, which is RQ. Add them all together, and that's the maximum willingness to pay for all of those Q units together as the area underneath the demand curve. Okay. So here's an example, right? So here the demand function is that point demanded is equal to 5 minus 1/5 the price. Just remember, of course, that when we draw the demand curve, we're actually drawing inverse demand. So I inverted the demand function, and we get prices equal to 25 minus 5Q. So our demand curve, we see that when Q is 0, the price is 25, and when the price is 5, Q is 0. So there's our demand curve. All right, so we want gross consumer surplus, say, of consuming 2 units of good X. I guess I call it good Q here. 2 units of good Q. We take the area underneath the demand curve up from Q equals 0 up to Q equals 2. Now, in this case, it's easy to calculate the area demand curve, right? Because it's just sum of a rectangle and a triangle, where we can see the rectangle here is just has a base of 2 and a height of 15. 2 times 15 is 30. And then the rectangle has a base of 2 and a height of 10. So half the base times the height is 10. Add the two together, and we see the gross consumer surplus is $40. All right, so the total utility, if you have a quasi-linear utility function here, the total utility consuming 2 units of the good is equal to $40, right? But again, in general cases, this is going to be approximation of your total utility consuming 2 units of the good, right? So we call that your gross consumer surplus. That's how much 2 units is worth to you. That the maximum you're willing to pay to consume 2 units of the good is $40, right? If you had to pay more than $40 to buy 2 units of the goods, you say, no thanks, I won't buy it. If you pay less than $40 for 2 units of goods, you're happier, right? You say, that's great, I'm making money, right? I pay less than $40, but it's worth $40 to me. Okay, so that's the idea of gross consumer surplus, the maximum you want us to pay for that many units of the good. Okay. Now, as I pointed out, we don't use gross consumer surplus, we use net consumer surplus. So let me motivate what net consumer surplus is for you. Now, we'll go back to quasi-linear preferences here. The V of X we did in quasi-linear utility is utility from consuming good X. That's our gross consumer surplus. right? That's the total utility you get from consuming X, all right? And remember, expenditure in good Y is the quantity of good Y, that's expenditure of all the other goods, is simply equal to the amount of income you have left over after you bought X units of good X. So it's M minus PX. All right. So put it together, we see that your utility of the bundle XY, plug it into the quasi-linear utility function, is equal to the gross consumer surplus of good X, right? That's the total utility you get from good X, is equal to the maximum willingness to pay for good X, which is the area underneath the demand curve, up to from X equals 0 to up to X units of X. And then utility you get from good Y is M minus PX, right? So the way of thinking about this is that when you consume the bundle XY, right, you're getting a gross consumer surplus of good X, right? That's how much X is making you happy. However, in consuming good X, you had to pay for it. And how much did you pay for it? You pay P times X. Well, that P times X means that you have P times X fewer dollars and therefore fewer units available to buy of good Y. So by buying X units of good X, that means that you have PX units, fewer units of good Y. Right? So your utility of good Y is going to go down by PX. All right? So therefore, your net utility of consuming X units of good X is your utility of consuming good X, your gross consumer surplus, minus the utility you lose by not being able to consume PX units of good Y. So it's the gross consumer surplus minus PX. Okay. All right, so think about that if it doesn't make sense the first time around, because remember, good Y has a price of 1, right? So if you're spending PX dollars on good X, that's your expenditure on good X. That's PX dollars fewer on good Y. Since good Y costs $1, that's PX units fewer of good Y, right? So by buying X, you get the gross consumer surplus of good X, how much it makes you happier, but you're losing PX of good Y. So your net utility is the difference between those two. Okay, so that gives us our net definition of net consumer surplus, or what we just call consumer surplus. So the consumer surplus of Q units of good X is the difference between the area underneath the demand curve, the gross consumer surplus, right, which is what we call the maximum willingness to pay for that many units, and what you actually have to pay for that many units, which is PQ, right? So the net utility, we said, is the difference between the gross consumer surplus minus PQ. So it's the difference between the maximum you're willing to pay for the unit given by the area unique demand curve minus what you actually have to pay for the Q units, which is P times Q. So that difference is the net consumer surplus. So it's a measure of your net utility from consuming X, Q units of X. Okay, so let's see what it looks like on our diagram. All right. So we know the gross consumer surplus of consuming 2 units of good X is $40, right? It's worth $40 to you for good X, but you had to pay $30, right? P times Q is 2 times 15, right? So that's $30 fewer of expenditure in good Y that you can't consume now because you're spending it on good X. But you still have a net positive utility here, as you can see. The good X, 2 units of good X was worth $40 to you. You paid $30, so the difference is $10, right? And that's your net consumer surplus, or as we call it, just consumer surplus, right? So here you can see that the consumer gains by buying 2 units of good X. They gained $10. They were willing to pay a maximum $40. They only had to pay $30, so they have a consumer surplus of $10. Okay, that's typically going to be the case with downward sloping demand curves, and when the firm can only charge a single price for the good. So every unit you buy at the same price P. If I have time, I probably won't. When I come to monopoly, I can talk about a price discriminating monopolist who can charge different prices. And the reason they do that is to try to grab some of your consumer surplus, take it from you and give it to them. But that's getting ahead of ourselves, and we may not have time in this course. So here's the net benefit to the consumer, and we call that the consumer surplus, right? How do we calculate that area? Well, we can just calculate that area of that triangle, half the base times the height, base is 2, the height is equal to 10. So half the base times the height is equal to $10. Okay. Now, that was calculating the consumer surplus at a particular price. Typically, when doing policy analysis, what we were interested in doing is seeing how consumer surplus changed from a change in policy. Right? So a change in policy, like putting, say, a tax on imported steel, raises the price of steel or to consumers, or in more realistic terms, the price of goods that use steel that consumers use. So perhaps stainless steel washing machines or so on and so forth, anything that uses steel will go up in price. Right. So what we're going to do is say, okay, the change in policy has changed the price and therefore changed quantity demanded. How has that changed consumer surplus? So we're interested in looking at the change in consumer surplus. So for example, suppose the price of X goes down from $15 to $10 because of a government program, maybe a subsidy, right? They subsidize the price of X. Maybe these are solar panels and they want to encourage people to use more solar panels. So the subsidized solar panels, so it only costs consumers $10 to buy it now instead of $15, right? What's the benefit to consumers? And by the way, just to get ahead of ourselves slightly here, you can always assume, or you know, that if the price goes down, right, then you're paying less for the good, right? And therefore, your consumer surplus will go up, right? Your net consumer surplus. That is the difference between the maximum you're willing to pay and what you actually have to pay is increasing because what you actually have to pay goes down, right? So consumer surplus always goes up when the price goes down. All right, and when the price goes up, consumer surplus goes down. So when it comes to actually asking what's the change in consumer surplus, just remember to make it positive if the price goes down, make it negative as the price goes up, and that just saves you a bit of grief. Okay, so here's an example. The price went down to $10. We could calculate the consumer surplus when the price is 10. So you can see here when the price is 10, I didn't write down the demand function. There it is down there. You can see when the price is 10, put it into the demand function, quantity demanded is 5 minus 2, which is equal to 3. So the quantity demanded is now 3. All right, and so we can calculate the area below the demand curve, the maximum you're willing to pay, and above the price. All right, so the difference between the maximum you're willing to pay and what you actually have to pay, and that's our consumer surplus. And you can see again, it's a triangle, half the base times the height. The base is 3, the height is 15, and that area is equal to 2250. So remember, before it was equal to $10. Consumer surplus was $10. Now it's 2250. So that's a gain of 1250. Okay. Now in this case, to calculate the change in consumer surplus, like again, pointed out for fall in price, you know it's got to be positive. If it was an increase in price going from price of 10 to 15, you would say that would be a loss, right, of 1250. Okay, so just be careful about that. You would put a minus 1250 in that situation. Now here, when we calculated the change in consumer surplus, what we did is we calculated the original consumer surplus and the new consumer surplus, and we took the difference between the two. But we don't have to do that, right? A quicker method here would be just to calculate the change directly by taking the area to the left of the demand curve between the two prices, right? Because above the price 15, that little triangle, that's the original consumer surplus when the price was 15, right? The bigger triangle, when the price is 10, that's the consumer surplus when the price is 10. So the difference between those two is that pink area, the shaded area in pink or red, whatever color that is. All right, so to calculate the change in consumer surplus, we can just calculate that area there to the left of the demand curve between the two prices. And again, as I pointed out, here the price fell from 15 to 10, so it's actually going to be a gain. If the price increased from 10 to 15, then there'd be the negative of that area. Okay. And I call it demand for movies. I don't know why I changed it from Q to movies, but I did there. Okay, so how to calculate that area? So again, we have a rectangle and a triangle here, right? So here the rectangle is equal to base of 2 and the height of 5. which is 10, and the triangle has a base of 1 and a height of 5, which is 250. 10 plus 250 is 1250, same answer as expected. But the nice thing about this is it gets a nice little interpretation. Look at the area of the rectangle. Right? What is that telling us? That's telling us, remember originally when the price was 15, you consumed 2 units of the good. Right? So when the price falls to 10, notice that your utility, if it's quasi-linear utility function, the gain from consuming those first 2 units has gone up, right? You don't have to pay $15 for those first 2 units. You only have to pay $10 for those first 2 units, and you gain consumer surplus equal to that area of that rectangle, right? So that's the benefit of the falling prices. You used to pay $15 for those 2 units. Now you only pay $10 each for those 2 units. So when I say $15 per unit for those 2 units. Now you only pay $10 each for those 2 units. So that's what that rectangle is measuring. The triangle measures the benefit of the falling price, allowing you to consume more of X. Right before, remember, at price of 15, you only consume 2 units of X. Now the price has fallen to 10, you consume 3 units of X. And the extra utility you get from consuming that third unit of X is that triangle there, $2.50. Right? The price goes down to 10, you consume more X, and the consumer surplus you get from that third unit of X is that triangle. So it's just a neat interpretation of that. Okay. Now, the one issue to point out about that is those examples were linear demand curves. But what happens if I give you a nonlinear demand curve? Well, in that case, we're going to have to use calculus, right? We're going to have to integrate. But a couple of issues. So one is, notice with a nonlinear demand curve, it may be the case that the demand curve does not cross the vertical axis, right? So that's why this method of calculating the change in consumer surplus by calculating the area to the left of the demand curve between the prices is preferable to calculating the consumer surplus before and the consumer surplus after. Because if you try to calculate the consumer surplus before and after, it may be that it's infinite, right? Because the curve goes off to infinity as X goes towards 0. So this would be a preferable. That's why this method is preferable for calculating the change in consumer surplus. The second issue is, I said we want to, you use integral calculus to calculate areas. But remember, when you do integral calculus, you're calculating the area underneath the demand curve to the horizontal axis, right? But here we want to calculate the area to the left of the curve to the vertical axis, right? But that's not a problem, of course. Right? All we do is we can rotate the axes, put price on the horizontal axis, X on the vertical axis, and now price is on the horizontal axis, so it'd be the area below the curve to the horizontal axis is what we want. But remember, when you do that, then the curve is no longer going to be the inverse demand, it'll be our regular demand, right? The demand function X equals 1 over P minus 1, not P equals 1 plus 1 over X. So the upshot is, when you go to integrate to calculate the consumer surplus, you want to integrate the demand function, not the inverse demand. Okay, so that's what we want to do here to finish up. All right, so we want to calculate the integral of the curve to the left to the vertical axis, and then you can ignore this thing. I made it all more complicated here. You can ignore all. Let me. This, you may find this part. I don't know if I can. That's probably more complicated than it's worth. The easiest way to remember this is the change in consumer surplus. If you want to calculate change in consumer surplus, is you want to take the integral of the demand curve. So remember again, the demand is 1 over P minus 1. Right? So not the demand curve, demand function is 1 over P minus 1. So take the integral of the demand function, 1 over P minus 1, and you want to integrate it with respect to P, so dP. And then you put the prices in there. Right? We're going from price of 2 to price of 3 in this example. And then what I want to illustrate here, notice I put a minus sign in front. Right? The only thing you need to be aware of is that I talked about this before. If the price goes up, you know that the change in consumer surplus is negative. Higher prices reduce consumer surplus. If the price goes down, you know it's going to be a positive number. Right? So don't worry about those first 2 terms. just say, okay, I know that the price is going up, therefore the consumer surplus has to be negative. I'll put a minus on the front. If the price is going down, then don't put a minus on the front. Okay? All right, so what is the integral of 1 over p minus 1? Well, it's actually pretty simple. Right? Remember, the integral is the antiderivative, essentially. So what when you differentiate, it will give you 1 over p minus 1. Well, you know when you differentiate ln of x, that's just 1 over x. So if you differentiate ln of p minus 1, that's just going to be 1 over p minus 1. All right, so the integral of 1 over p minus 1 with respect to p is just going to be the ln of p minus 1. Of course, I have the minus sign in front of the integral, so it's a minus ln of p minus 1. And now evaluate it at the two prices, plug in the price of 3, right? We have minus ln of 2 minus the plugging in the price of 2. So minus is a plus. So it's going to be the ln of, when you put in 2, it's going to be the ln of 1. So we have minus ln of 2 minus ln of 1. So it's minus ln of 2 plus the ln of 1. Now, if you remember, the ln of 1 is just 0. If you don't remember, put it in your calculator. So the change in consumer surplus is just minus ln 2, which is minus 0.69. All right, so that's how you would do it for nonlinear demand curves. It's just take the integral, but you're taking the integral of the demand function, not the inverse demand. And you just remember, if it's a fall in the price, make it positive. If it's an increase in price, make it negative. All right, so thank you for sticking around. I want to get that one done before the break. So now we're all done with consumer theory. When we come back from the break, I'm going to look at producer theory. So if you're looking at the Serrano and Feldman textbook available freely online at Cambridge University Press, that'll be chapters 8 and 10. If you're looking at Varian, I can't remember which chapters are in. I tend to use Varian a bit closer here. Varian's textbook, Intermediate Microeconomics. But as usual, you can just use my lecture notes. So I'll be posting those lecture notes over the break. Secondly, I'll be posting tutorial 4, should be available right after this lecture. And then we'll take that up when we come back. So remember, you have a 2-week break, and you have the assignment 1 due on April 10th. If you'd noticed, if you haven't been following the announcements, I created a discussion board. That was to replace the fact that I can't have physical consultation hours anymore at school. So I wanted to have a consultation on the discussion board. But I will be there. I think at the time I picked was Wednesday, 1 to 2. You can check the discussion board for the exact time. Maybe it's Wednesday, 3 to 4. I can't remember which one. Yeah, I think it's Wednesday, 3 to 4. I'll be there monitoring Wednesday, 3 to 4, the discussion board. If you have any questions, that'd be like my physical consultation hours were before. However, because it's up there, I will come in occasionally and check during the rest of the week. But I won't necessarily be there, so your question won't be necessarily answered right away, but I'll try to get back to it if I notice it within 48 hours. All right, so you can use that to ask me questions. Now, it's not a replacement for a tutorial consultation. Tutorial questions, I want you to go to the tutors and ask them, but it's something you maybe want to ask about the lecture notes or in general about the course or whatever, or if you can't get satisfaction from the tutor about some tutorial question, then I want you to come to me. But I don't want everybody asking me, ask your tutor first and get that resolved so that we don't get swamped with all the tutorial questions. Okay? All right, so what I want you to do, obviously, is to work on your assignment over the break, but I'm also going to give you tutorial questions that's going to test you doing elasticities and consumer surplus. And then if you can, read ahead on the using the Serrano and Feldman textbook, chapters 8 to 10, read about producer theory, which we'll be taking up when we come back. And then when we come back, remember, that'll be the remaining 7 weeks of the course, weeks 6 to 12. All right, have yourself a nice break, and hope to hear from you, or you'll hear from me at least, in 2 weeks. Cheers.